Okay, we're going to talk about factoring, and this part is assuming that you already know how to factor normal things, but we're going to talk about how to tell the difference between factoring a perfect square and the sum and difference of squares. And so notice that as you look at these three examples over here and then the three examples here, the sum and difference of squares has two terms in it. These were the answer to FOIL, where this is the F and this is the L, but the O and the I had canceled each other out, so there's no middle term. You could actually look at them as a 0x minus 9, like that. That would be one way to consider them. This is the F, the O and the I, and the L. But I'm going to come back over here to this one in a moment. This is F, O, I, and L, and so we know that we need to find the middle two terms that made negative 12x. And so when we factor perfect squares, we can do it the traditional method, the AC method, where you multiply the first and last, you list the terms, put the signs on them accordingly, and then find the set that equals the middle term. That totally works. But they're trying to show you that you can actually have a little shortcut here. If the first term and the last term are perfect squares, then you can go ahead and set them up without using the long method. So we know the first term had to be x and x to make x squared when they were multiplied. And the last term was made by 36. So if you find the square root of the first term, you find out that we put x in both of these. And if you find the square root of the last term, you find out that this would be 6 and 6. And they both, when it's a perfect square, they're going to have the same signs. If they have different signs, it causes it to cancel out like this. So we don't want it to cancel out. We still have a term here. So we want them to have the same sign, and the sign is whatever you see on the middle term. So I know both of these are going to say minus. And so there it is. Now we would say this is x minus 6 squared. So down here we have the square root of the first term and the second term, or so to make the first in each set x, the square root of the last term is 5, and the middle sign is minus, so this was developed by doing x minus 5 times x minus 5, also known as x minus 5 squared. Down here we do the same thing. 16 is a perfect square. So let's see, x squared and 4, and then the sign of the middle term. Now, you could have these where they're not perfect squares. So you want to check all of these to see if they really are truly perfect squares. Like up here, when I did x minus 6 and x minus 6, if I was to check it with FOIL just to see if it does come back to this, your outer edges would give you negative 6x, the inner edges would be negative 6x. And so those two, when they combined, really would create a negative 12x. Again, outer edge, check the outer and inner. 1 times negative 5. So these both come out to negative 5x, which produces, when you put them together, a negative 10. And here we get 4x plus 4x, and that produces a positive 8x. So you got to just double check. You can't just assume if you see the first and last term as perfect squares. You can't assume that it's a perfect square problem. You have to make sure that middle term works itself out. So over here, if you have sum and difference of cubes, how you can tell is, first of all, they have to say minus. So this one down here, it actually is considered prime, because if it doesn't say minus and it has two terms that's squared, then we can't do the problem. Now later on we're going to learn about cubes. We can do cubed things, but we can't do squared things unless they say minus. So up here, this would be the square root of that term, x in each set, and the square root of this 3 in each set. And then in order for them to cancel out and cause a 0x, one of them has to be plus and one has to be minus. So you cannot write this squared like we did with these over here, because squared means it's exactly the same thing being multiplied over and over again. So then this one would be x plus 6 and x minus 6. And again, this one would be prime.